Let us continue the second part of this chemical bonding lecture. As we have already explained, the chemical bonds are classified into four types. Now, based on the strength, we can classify as strong bond, weak bond. Strong bond means that this is interatomic, whereas a weak bond means this is intermolecular. So the energy is approximately greater than 200 kilojoule per mole. Whereas they are in the range of say about 2 to 42 kilojoule per mole. The strong bond we discussed yesterday, they are classified into ionic bond, covalent bond, coordinate bond or dative bond, and then metallic bond. And ionic bond can be easily understood by putting that is EP plus En. What is that? Electropositivity plus electronegativity. Covalent bond, in this case, there is no change, difference in electronegativity. So this is electronegativity plus electronegativity. Of course, you know this is polar and this is non-polar. And the dative bond is a kind of a donation of a pair of electrons to the acceptor. So metal to ligand. So donation. A pair of electrons is donate pair of electrons. In this case, there is a transfer of electrons. So electron transfer. Here it is a mutual sharing of electrons. Then what about the metallic bond? That is electropositivity plus electropositivity. And when you consider the weak bond, it is intermolecular. Its energy is less, and it, in fact, it can be further classified into hydrogen bond, that van der Waals force, that is intermolecular force of attraction, or you can call it cohesive force, or it can be called van der Waals force. Van der Waals, you have to write V small a n and d e or then capital W a q. Van der Waals force. And this can be further classified into, of course, this one, intermolecular hydrogen bonding, intramolecular hydrogen bond. So these are about the bonding. Then we discuss about the Lewis structures and how these Lewis structures are formed. Then I was, yeah, tell me, which one? V of Van der Waals force. Where is it? Cohesive force. Cohesive force means Van der Waals force, which is nothing but the intermolecular force of attraction. Then I was discussing about the ionic bonds, where I was explaining about the sodium chloride. For example, sodium has got 1s2, 2s2, 2p6, 3s1. That is sodium 11 electrons. So, and here you have got chlorine. So the chlorine has got that is 1s2, 2s2, 2p6, 3s2, 3p5. So it means it has got 5 electrons in the outermost shell. So this can be represented as simply 2, comma 8, comma 1. And here it is a 2, comma 8 and 7. So the outermost electron is represented here. And for chlorine, there are 7 electrons. So you can represent the outermost electron as pairs like this. Now what happens? This pair of, electron is transferred here, sodium. So that the sodium becomes a sodium plus cation, Na plus. So it attains the stable structure, that is octet. According to octet rule, 8 electron system is stable. So it has got the stability now. Similarly, chlorine. So chlorine has got 1 electron from sodium. So 2, 4, 6, 8. So it has got 2, 8, 8. And this is also obeying the octet rule. Thereby it attains the stability. Right? So similarly, we can explain the various compounds. For example, lithium oxide, Li2O. What is the electronic configuration 2, comma 1, because 3 atomic number for lithium, is it not? So I can put lithium 2, comma 1, right? And it means it has got 1 electron here. Plus, what about oxygen? We have got 2. What is atomic number of oxygen? 8. So you have 2, comma 6. Okay. So here the outermost has got, that is 2, 4, 6, like this. And in fact, from this side, 1 electron will come and pair. And from the another side, 1 electron of lithium will come and pair. Are you able to understand this? So that you have got Li2O. So it means the Li will be like this. So it has got to 1 plus. And what about oxygen? It attains 2, 4, 6, 8. And what about this lithium? It has got this with plus. Okay. So it has lost 1 electron. Which one? 2. What about this lithium is also lost 1 electron and attains the stability. 2 and 8 electron system are stable. And this also attained 8 electrons. That is 2, comma 8 oxygen. So in that case, all are stable. So yesterday we were discussing about the various, particularly the carbon dioxide and water. And you can go through the Lewis structures of, you have to practice the Lewis structures of all these compounds. I'll give you a worksheet and try to complete that one. Okay, so this is regarding the Lewis structures. And you should know something about the conditions of formation of ionic bonds. Take down. What are the conditions? The conditions for the formation of ionic bond. So let us list the conditions. There are 4 important conditions. Take down. What? Low ionization energy of metal atom. Of metal atom. Second, high electron gain enthalpy. EG means high electron gain enthalpy of non-metal atom. Third, electronegativity difference. Electronegativity difference between the reacting species or atoms. Between reacting species or atoms in this case, the participating atoms. Then fourth one is enthalpy, lattice enthalpy. Okay, lattice enthalpy. Now let us discuss one by one. Low ionization energy of matter. First of all, you should know what do you mean by ionization energy. Okay, ionization energy is the amount of energy required. It is the amount of energy required to remove the most loosely bound, the most loosely bound electron from an isolated, from an isolated atom to form a positive, to form a positive ion. It means, so let me consider this sodium. It has to lose. So let me say this is sodium solid, and the sodium solid becomes a sodium gaseous atom. So from the gaseous atom, this is a solid. Actually, metal becomes a molten liquid. After that, it becomes a gas. Otherwise, you can get it as a sublimation also. So from sodium solid to sodium gas. Now, this is the isolated atom. Do you understand the meaning of isolated atom? So from this isolated atom, how much energy is required to remove the electron so that this sodium metal becomes a sodium plus ion capital. So here you have got what is atomic number? 11. So you have got 2 and then how much? 8, then 1. So here it becomes a 2, 8, right? So what is the amount of energy required? The amount of energy required here. So this is called the ionization energy. Do you understand this point? And what is said clearly? Most loosely bound. It means the outermost electron. So that will be the most loosely bound. All other electrons are tightly bound with the inner core of the atom, that is the nucleus. Are you able to understand this? So, what is ionization energy? It is the energy required to remove, for example, let me consider sodium. It has got 2, 8, and 1 electron. So, they are packed like this. The innermost nucleus is here. So, the 2 electrons in the K shell, L shell, 8 electrons, they are tightly bound. But this guy is what? Loosely bound. And this loosely bound, what is the energy required to take away this loosely bound electron? That is called ionization energy. I hope now you could be able to understand clearly about this ionization energy. Okay. So let's have the ionization energy. Take down this point. This is very important. Lesser the ionization energy of a metal atom, greater will be the case of losing the valency electron, losing electron, tendency to lose electron. Do you understand this? So greater will be the tendency to form ionic bond, tendency to form ionic bond, and thereby it becomes cation also. Are you able to understand this point? Now let us move to the next one. What is the second one? The first one is ionization energy of metal atom. I hope you are clear with this one. Now, what about the next one? That is increase of electron gain enthalpy. That is high gain of electron enthalpy. Okay. So high electron gain, electron gain enthalpy. This is also called electron affinity. Okay, take down EA, electron affinity. So the electron gain enthalpy is the amount of energy release. Remember here the energy required to pick out the electron, to remove the electron, and what type of electron? The most loosely bound electron, and where from? From the outermost shell. Why? Because it is an isolated one, so that we can easily remove. Now in this case, electron affinity, that is the amount of energy, take the amount of energy released. You must note down this point. Released when an electron is added. Okay, when an electron is added, when an electron is added to an isolated gaseous atom, to an isolated gaseous atom. Are you able to follow? For what? And then when electron is added, it becomes what? To form negative ion. Okay. Now let me consider chlorine. So what is the electronic configuration of chlorine? 2, 8, and then tell me 7. Okay. Now you know what do you mean by valency? What do you mean by valency? Tell me. It is the number of electrons available in the outermost shell. Okay. Take down. It is nothing but binding tendency. Right. For example, calcium has got two valency. Why? It has got two electrons in the outermost shell that can interact with another elements. Similarly, sodium it is one. Got it? For hydrogen it is one. For potassium it is one. So likewise it goes. For oxygen it is two. In that case of chlorine, how many chlorine atoms are there? It is reasonable. For example, when I say sodium, it has got 1s2, 2s2, 2p6, 3s2, 3s1. So it is outermost shell electron and thereby it is involving in the bonding. So the outermost valency electrons can be directly called valency of the sodium. So it is 1. So it is agreeable. But what about this chlorine? This chlorine has got 287, the last one. That is, we can let us expand it. 1s2, 2s2, 2p6, 3s2, and 3p5. So let me consider the last shell. This is paired 1, 3s2. What about this 3p5? You've got three shells, three subshells here. 1, 2, 3, 4, 5. What I said, that is, you've got totally 7 electrons, right? And what is the valency here as far as chlorine is concerned? Pressure. Why 1? Why not 7? Let me answer. See, I said the number of electrons available in the valency shell, that is in the outermost shell, and that should be called the valency of the respective element. But in this case, you have got seven electrons. In spite of having seven electrons, you don't claim that the valency of a chlorine is seven. No, it is one. Why? Because instead of, see how the binding can occur, how the valency can occur by exchanging the electrons, right? So instead of exchanging seven electrons to some other guy and getting a bond, simply it will take one electron and what? Attains the octet configuration. Do you understand? So instead of losing seven electrons, it is very easy to accept one electrons, and that is why in this case, since it accepts one electron, so the interaction is only one, and you can say the chlorine has got the valency one. Do you understand this? Okay. So here, what happens? It has got already seven electrons, and you are adding one more electron. It is I mean, it has got a surplus electron, subsequent electron in the third shell. But voluntarily, you are pushing one electron on them. For example, when you are almost, that is, when you don't feel any hungry, your mother comes and delivers some sweet. Oh, you take extra. This one also means will you accept? You will accept but reluctantly. It means you will release some energy. So in this case, the energy is released when electron is added, and that is why it's called electron gain enthalpy. So let me consider this chlorine. It has got 287. Now you are adding one electron. So it becomes a 288. So it attains a stability. But here, what has occurred? You have added voluntarily one electron. So what happens? So the energy is released here. Okay, so the energy is released. And this energy release is called what? Electron gain enthalpy. So the energy release is represented by minus. So we can put minus EA. So this is called electron affinity, and it can also be called electron gain enthalpy. So this occurs in the case of non-metals, chlorine being non-metal, so it has got that character. Okay. So here the higher one, so how it should be indicated? The electron gain enthalpy is always indicated by minus EA, take down. And what about this ionization enthalpy? That is indicated by, because the energy is required here, right? So this is plus IE. You are taking in. Okay. Now, so higher the value of negative electron gain enthalpy, that is electron affinity, greater will be the formation of anion, that is negative ion, X minus. Are you able to follow? Hence, greater will be the tendency to form ionic compound. So this is the another important point. So any doubt in this? Shall I proceed? Right. Third one. Electronegativity difference between the reacting atoms. Take down. Electronegativity difference between the reacting atoms. So in this case, larger the difference. What is that? Larger the difference or wider the difference between the electronegativities of the reacting species, higher will be the what? The ease of formation. That is, greater will be the ease of formation of ionic compound. Okay. Now let us move to the fourth point, lattice enthalpy. What do you mean by enthalpy? It is nothing but heat content. That's all. Changes taking place in at constant pressure during the reaction. That is called enthalpy. So it is represented generally by H. So it is a function of temperature and pressure. Whereas there is one more term called energy, internal energy. It is a function of temperature and volume. So we will discuss in detail about these two aspects, thermodynamic parameters in thermodynamics. Anyway, you should know something about enthalpy now. So the lattice enthalpy is something concerned with the ionic solid. So it is concerned with the ionic solid or the crystal. So when you say crystal, definitely the term arises crystal lattice, the regular pattern lattice. So it is the amount of energy required to completely separate, completely separate 1 mole of solid ionic compound, 1 mole of solid ionic compound into gaseous, into gaseous constituent ions. Now let me explain. You got the sodium chloride. It is in the solid state. So the energy required for this sodium chloride salt to become Na plus and Cl minus ion. It is a gaseous constituent. So gaseous cation. And what about this? Gaseous anion. Do you understand this? So, see, is it possible to form a Na plus and a Cl minus ion just by crushing the sodium chloride? For example, I would like to have this sodium ion, cation, and chloride ion, anion. How can you isolate this? Can you crush it? No. Can you dissolve it? No. Can you melt it? No. Then what? See, it is the tendency to split this. It is for which we require certain amount of energy to split into Na plus and Cl minus. Don't mistake that taking sodium chloride salt and dissolving in water, you will be able to get sodium ion and a chloride ion. That is ruled out. You cannot. You will be having only ionic doublet. That is, you will be having NaCl, NaCl, NaCl pairs. And it should be further split only by additional energy. For example, let me electrolyze it. Let me introduce two electrodes inside the sodium chloride solution. Then what happens here? NaCl becomes Na plus and Cl minus. And Na plus ions will be moving towards the cathode. and chloride ions will be moving towards the hand. And that is why we call it electrolysis. Okay. So the lattice enthalpy is something great, that is, you cannot imagine as though it can be mechanically split. You cannot do it even with a heavy axe or even a heavy hammer. You cannot claim that I am going to break the sodium chloride ion into pieces as Na plus and Cl minus just by crushing, melting, dissolving. Nothing is possible. Then it can be done only by the lattice enthalpy. So that chemical, you just imagine chemical bond is how stronger it is, right? So we need a sophisticated technique so that we'll be able to break the chemical bond. And that is why, so in the previous class, I was discussing about the physical properties and chemical properties. The physical properties are resulted by the breaking of physical bonds, and that can be done, that can be applied by mechanical means, mechanical forces. Whereas in the case of chemical bonding, you cannot do it mechanically. So it has to be influenced chemically. And that is why here I am talking about this lattice energy. This lattice energy, please make a note of it. This depends on various factors here. Take down. One is the charge of ion. Charge on ion. This is one of the very important factors. Second, the size of the ion. That also take a very important role. Okay, take down the size of the ion. So these two are very, very important. Size of the ion. So these are the two factors that governs the what? Lattice energy. Now let me consider this a sodium chloride, NaCl. Okay, NaCl. You know very well Na plus Cl minus. And here both of them are univalent. So you can call it univalent. Okay, univalent. And it has got the value minus 758 kilojoule per mole. Now let me take calcium chloride, CaCl2. What about this? Calcium has got bivalent. So you can put it bi, and chlorine is univalent. So biunivalent. So this is a biunivalent species. It has got minus 224, 2254 kilojoule per mole of energy, lattice energy here. And what about magnesium oxide? MgO. Both of them are what? This is 2 plus, this is minus. This is 2 plus, this is 2 minus. So in this case, this is called bivalent. Do you understand this concept? And here the energy is minus 3932, 3932 kilojoule per. Now, when you compare this, you know very well this 758 is less than that of a calcium chloride, and this calcium chloride is less than that of the magnesium oxide. Okay, so in this case, the charge on the ions, higher the charge on the ions, are you able to observe here? Higher the charge, higher the charge on the ions, greater is the force of attraction. For example, here, what is the lattice energy? 3932. It is huge compared to 758. Why? because both of them are higher charges. So higher the charge, greater is the force of attraction. So you need more effort to break it. Okay. So here you can understand that larger amount of energy is released. Okay. Take down. So in this case, larger amount of energy released. That is, this larger energy is very, very important, and that is why we talk about the charge. So higher the charge, greater will be the lattice energy. Simply you can take it like this. Secondly, yeah, tell me, NaCl is less. No, 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 you should not go like a negative value. So that minus indicates the release of energy, right? When I put minus, it indicates the release of energy. It is not like a minus 2, minus 3, which is bigger. You will say minus 2, but it is not like in this case. Do you understand? This minus indicates the release of energy, right? Then, now let us talk about the size of the ion. So I was explaining about the charge here. Now, size. What about the size of the ion? Let me compare once again. Let me say NaCl, the same NaCl, and let us consider NaBr. When you compare chlorine and bromine, here the energy, lattice energy is 758 in this case, whereas here it is minus 752. Are you able to follow? It means higher the size because the bromine is of a higher, I mean, atomic size compared to the chlorine. Of course, sodium is common here. So size of the ion, anion is bigger. So bigger the size, that is larger the size, take down. Larger the size of the ions, larger is the internuclear distance. Internuclear distance, right? And when the internuclear distance is larger, it is easy to remove the ions, is it not? So lower will be the force of attraction. Okay, take down the force of attraction. So lesser will be the lattice energy. So don't forget all these things. So as far as charge is concerned, higher the charge, higher will be the force of attraction, and thereby the lattice energy is high. Regarding the size, in this case, you know very well, this has got more lattice energy than that of Br. Why? It is because of the size of the Br. So the size has increased, and thereby there is an increase in the internuclear distance, and that is responsible for the lowering of force of attraction, and that is why the lattice energy is also decreased here. Okay. Now, here I would like to stress one important point is in the help of it. The lattice enthalpy, take down, lattice energy or lattice enthalpy plus electron gain enthalpy, which is also called electron affinity, together is greater than ionization enthalpy. Please note down this. Greater than ionization enthalpy. So later we'll be deeply studying about the Born-Haber cycle. Okay. Now let us discuss about the characteristics of ionic compounds. characteristics of ionic compound. The compounds in which ionic bonds are present are called ionic compounds that you know. And what are the characteristics? Let us discuss one by one. Physical state. Second, melting point and boiling point. Third, solubility. This is another important parameter to be discussed. And four, electrical conductivity. Electrical conductivity. Ionic reactions. Ionic reactions. Non-directional character. Non-directional character. Non-directional character. Now let us discuss one by one. Physical state. Generally, they exist as crystals, crystalline solids. Here, a popular term called crystal lattice. Crystal lattice is nothing but an orderly three-dimensional arrangement of cations and anions held together by Coulombic interaction. Okay, so what is crystal lattice? It is the orderly arrangement, 3D arrangement of cations and anions held together by Coulombic force of attraction. I will show you one diagram. For example, let me consider sodium chloride. It has got face-centered cubic crystal. The type is face-centered cubic crystal. Now you draw a cube like this, and you can split this further like this. So vertically I have divided, and vertically I am dividing like this also. Then horizontally I am cutting this. Now can you guess how many pieces I have obtained, how many cubes I have obtained? Can you guess? 8. Let me draw one cube here. Okay, right? And this is another cube. Are you able to follow? I hope now you are able to understand. Okay, at the bottom you got two cubes in the front. At the back you got another two cubes. So totally 4. So 4 plus 4, 8. So you got 8 cubes, right? So here you have sodium is represented by dot. Chlorine can be represented by round. So this is sodium, this is chlorine. So here I have got the sodium and I got chlorine here. And this will be the next atom. So here I have got chlorine. And here I have another 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 chlorine. Now let me join this. Okay. And what type of configuration? I mean, you are able to get the shape. Can you identify the shape of this? Anyone? Octahedron, right? Are you able to follow? Octahedron. You have got the plane. On the square plane, you have got a pyramid, and it's a bipyramid, right? So it means octa, eight edges are there. So octahedral. And you can find, see, one sodium is surrounded by eight chlorine. Similarly, this chlorine will also be surrounded by eight sodium atoms. So likewise, it goes on. So now you can have the complete lattice that is called the crystal lattice. And they are attached by themselves through the Coulombic force of attraction because of the opposite charges. And that is why it is difficult to break it mechanically or manually. Okay, right. Now let me move to the next one. Melting and boiling. Ionic compounds generally they are tightly held together by strong electrostatic force. Electrostatic force is very strong. So huge amount of energy is required to break, right? That's why their melting and boiling points are high. Okay. Next, solubility. These compounds are soluble in water. So it means the polar solvents can dissolve the polar compounds. And here there is one important concept called hydration enthalpy. Take down. What is this hydration enthalpy? Hydration means surrounding of water molecule around the solute. For example, you have got the beaker containing water. So I am so lot of water molecules are there. I have dropped the sodium chloride here. So immediately what happens? All these water molecules will surround the sodium chloride in order to break into pieces. And this is called hydration. And if it is surrounded by generally solvent means it is called solvation. Solvation is the general term. Here it is hydration because water molecules are surrounding the solute. Okay. So it liberates that energy. So these ions may combine with the solvent to liberate the energy, and that's why it's called hydration enthalpy. Non-polar solvents cannot dissolve the polar compounds. So it means the polar compounds can be dissolved only by polar solvents. Okay, take down polar solvents like water. Then electrical conductivity. Ionic compounds are good conductors of electricity. Good conductors of electricity in aqueous solution, particularly in aqueous solution, that is water-based solution, or in molten solution. Okay, aqueous solution or molten solution. And it's called actually electrolyte. What is electrolyte? It's an acid or base or salt that can conduct electricity in liquid form, that is in molten form, that is in solution form. Okay. Then in the solid state, they do not conduct. Please note down this point. So this conduct only in solution form. A solid one will not conduct. Why? Because of the absence of free ions. Next one. Ionic reactions. The compounds can be split up into oppositely charged ions when they are dissolved in water so that they will lead to ionic reactions. So I'll explain about this. Ionic reactions. You've got sodium chloride. How they are going to be split? Na plus Cl minus. in presence of water, that is in as aqueous solution. Now let me take a silver nitrate, Ag plus NO3 minus. And this is also in the aqueous stage. Now when they combine, what happens? This chlorine will combine with the sodium to become AgCl, silver chlorine, as precipitate, the solid one. And then you are able to get NaNO3. So this is called ionic reaction. Okay. Then, and I was explaining about the, what is the last one? Non-directional character. Okay. So non-directional character is these ionic bonds are generally, let me finish, non-directional. Okay. Ionic bonds are non-directional because each ion is each ion is surrounded by opposite ions, oppositely charged ions. So the charges, they are distributed almost around the ion. So in this case, they are totally neutral because number of cations is equal to number of anions here. For example, let me take barium and chlorine. Barium has got the valency plus 2. What about chlorine? Minus 1. So when they form as a compound, what happens? So this take Ba2 plus can accommodate 2 chlorine. So put 2 chlorine. Whereas it has got only 1. So this becomes BaCl2. Are you able to follow? So in this way, they combine and make sure that the net oxidation state is 0. So that is the net charge is 0. So that is why it is non-directional. Okay.